Hello, Year 13 doubles. How are you doing? So I'm going to take you through a couple of examples from exercise 1D. And as I'm sure you will see in the following examples, things really start heating up in this chapter from exercise 1D onwards. So let's. I'm going to give you as well. I'm going to give you the advice of spending, today's lesson or Monday's lesson. It's Sunday for me today, but 2 hours on this, and that's what Monday's lesson and Tuesday's lesson is. It? Do I see you on Tuesday? Whatever. I see you 4 lessons a week. So first 2 lessons, if you can get all the way through 1D, I'm going to show you the. I'm going to basically use questions 1B and 1D to as examples to show you how this is done. But I'd like you to work through every question in the exercise after that, because I do think it's important that you get the hang of this skill. Now, these kind of questions can look really, really similar, but they have really quite different techniques for solving. So this is actually, I'll tell you which question it is. It's actually question 1. I've put it in a bit of a snazzy way, though, if I say so myself. I've said express sine 5 theta as a quintic polynomial in sine theta. In other words, I'm going to have a trigonometric polynomial of order 5 using just sine theta as my x, as my variable. So, okay, if I want to do that, and I start with, and it's important to please do contrast this after you've watched a whole video, contrast this with my second example, because they look really similar, the questions, but they have very different techniques. And I think the biggest challenge in this particular topic within this chapter is identifying when to use one technique and when to use another technique. Now, this one will not use the z plus 1 over z formulae, and you'll see that in a second. I'll introduce that halfway. All I'm going to do this first is I'm going to say, okay, we're going to use the Moivres. We're definitely going to use the Moivres. We're going to say, okay, note that cos 5 theta plus I sine 5 theta, and noting that this has a modulus of 1, we can obviously rewrite that as cos theta plus I sine theta to the power of 5, and that's how I'm going to introduce a quintic polynomial in sine theta. Now, I am going to, for like our own sanity's sake, and you will want to do this, believe me, they do not do this in the examples in the book, but you want to do this if you don't want to write cos and sine down a million billion times. Let cos theta equal c. Let sine theta equal s. Yeah, do yourself a favour in these, or you're going to be miserable. Okay, try and make your s different to your 5 as well. That's one of the things I have problems with in mine. So, okay, I'm just scrolling down the screen because guess what? We're about to do a lot of algebra. Now, what I can do is I can use a binomial expansion on the right-hand side there. Yeah, let's just call it c plus is. Yeah, and they often refer to this, I believe, as cis notation. CIS, cis notation. It's very common. It really is very common. So you've got c plus is to the power of 5. We're going to use binomial expansions. Now, I hope you're in a position now where you basically just kind of know the binomial coefficients for the first, say, 6 lines of Pascal's triangle. I know this one goes 1, 5, 10, 10, 5, 1, which really helps. And the power on, c should go down as the power on s goes up. So we're going to have c to the 5. Oh, but don't forget, we've got is. See, I'm already messing it up. Put it in brackets, is. Yeah, that's to the power of 1. And then we've got 10 c cubed is squared. Then we've got 10 c squared is cubed. By all means, please pause the video before I do this, so if you want to see if you get the last 2 couple right. Plus 5c is to the power of 4 plus is to the power of 5. Yeah? I think you'll agree with me that compared to what they do in the textbook where they're writing down every cos and sine, you will actually possibly escape with your sanity in this question if you just use c plus is rather than cos theta plus I sine theta, or you're going to go crazy. So I laugh at the people who haven't watched this video and are writing down cos and sine a million times. Fools. Okay, so that's what we've got for this, yeah, and we should simplify it. Now, before you start simplifying it, it's worth noting that I to the power of 1 is I squared is minus 1, I cubed is minus I, and I to the power of 4, Well, we're back to minus I times I, which is minus I squared, which is minus minus 1, which is 1. And we're back to 1. If you like, I to the power of 0 is 1. And it just loops round like that, because I to the power of 5 is I, and it goes round perpetually in a big old loop. I think I've mentioned this on another video I've done as well. Okay, we only need to go up to the power of 5 because we're going to be doing I to the power of 5 at worst. So then we've got c to the power of 5 plus, now we're going to have 5c to the power of 4 times I times s. Well, I to the power of 1 is I. We can't really do much with that, so I'm just going to write 5c to the power of 4 is. I'll take the brackets off just to show myself that I've dealt with it. Then we're going to have I squared, which is minus 1. So this is going to become minus 10c cubed s squared. Yeah, I'm getting rid of any i's where I can cancel them. I cubed, that's going to be minus I. So this is going to be minus 10c squared is cubed. Yeah, but I no longer need the brackets. And then we're going to go back to the positives. We're going to have 5c, I to the power of 4 is 1, so 5c s to the power of 4. And then lastly, I to the power of 5 is I, so I s to the power of 5. Yeah, now we've expanded that out, and what we can do now, because remember that this is equal to this, if I can just circle the really crucial thing which I've noted. I said note it, noted, make sure it's noted. Okay, what I can now do, of course, that is the same as cos 5 theta plus I sine 5 theta. So what I can do is I can do something very clever. I can equate coefficients. Because remember, this is the same as cos 5 theta plus I sine 5 theta. Notice the I on the left-hand side goes with sine 5 theta. So I'll point out right now that this would be the first step if you were doing a question express sine 5 theta as a quartic polynomial, or sorry, as a quintic polynomial in terms of cos theta, because I would have all of the i's. Yeah, yeah, sorry. I've just suddenly got really confused. If my question was instead express cos 5 theta as some kind of polynomial, then I could use this answer for cos 5 theta as well. Yeah, this works perfectly for the question express cos 5 theta or for the question express cos sine 5 theta as a quintic polynomial, because what I'm going to do is equate coefficients. So I want, consider. Let me put it like this. Yeah, I'll do it in black again. We need, I can't find my pen, sorry. We need sine 5 theta. You don't have to write this down normally. I'm just making a note of it. So we need only the coefficients with I involved. Only the imaginary parts. Yeah, that's what we call it, the imaginary parts. I'm going to rub this out in a second, but I'm just making it very clear. We need sine 5 theta, so we need only the imaginary parts. I hope that's clear. Sorry, I feel like I've kind of faffed my explanation up there. Okay, so what are we going to do? We're just going to look and we're going to say, okay, so the sine must simply be, okay, well, where have we got i's involved? We have 5c4s minus 10c squared s cubed, and then finally plus s to the power of 5. Yeah, that's all we need for sine 5 theta. So because all the other ones, just to make it clear, because I feel like I've faffed this explanation, all the other ones are for cos 5 theta. If you had to express cos 5 theta as a quintic polynomial in cos theta, then you would use c5 minus 10c cubed s squared minus plus 5c s to the power of 4. Yeah, and then you could turn that into whatever you wanted to turn it into. At the end, I can turn it into a polynomial in terms of sine theta real easy. I've got some coses in there, but remember, because cos theta c and sine theta's s, I can say that 1 minus c squared is, of course, s squared, yeah? And similarly, c squared is 1 minus s squared, yeah? I can use either of those, which I need. I want it in terms of sine, so I realised the first one I didn't need. It's the second one I need. I'm going to write that down as 1 minus c squared squared, because that would be c to the power of 4 times s minus 1 minus, sorry, s squared. I keep doing this. What a wally. I'm really confusing you, I bet. Sorry about that. Hopefully, though, this is quicker than the book. That's what I hope to show you. The book really makes a meal out of this. C squared is 1 minus s squared. So let's write it as 1 minus s squared squared times by s minus 10 times 1 minus s squared times by s cubed plus s to the power of 5. Yeah, beautiful. Now I've got it solely in terms of a polynomial in sine theta. So what is that the same as? 5 times 1 minus 2s squared plus s to the power of 4, but times by s at the end, minus 10 times, let's times that s cubed in there, s cubed minus s to the power of 5, plus s to the power of 5. Make sure your 5s and s's don't get muddled up here. And then at the end, I'm just going to do this real quick. So I'm just going to I'm going to tick when I've dealt with. Okay, I've got an s to the power of 5 there. I've got an s to the power of 5 here, and that's going to become 10s to the power of 5, positive 10s to the power of 5. And I've got an s to the power of 5 coming there from s to the power of 4 times s times by 5. Can you see that that's going to give me 16 s to the power of 5? I've then got, now for my cubes, I've got a minus 10s cubed here, and then I've got another minus 10s cubed. So this will deal with these two, and I'll get minus 20s. And then finally, I've got a 5 there, which I haven't ticked yet, so I need a plus 5 on the end. And so what have we shown? We've shown that sine 5 theta is 16 sine to the power of 5 theta minus 20 sine cubed theta plus 5. So yeah, my big hint for these ones, when you start with sine or cos of an argument, a multiple of the argument, sine 5 theta, sine 4 theta, sine 6 theta, and you want to write it in terms of some powers of sine or cos, that's when you don't need the z's. That's when you want to write c plus is and expand with binomial. Yeah? Okay, so that's one type of problem in this exercise. Let's look at the other type of problem, which is a little bit, I'd say it's even more tricky. Yeah, but before we do, I need to include a couple of simple results which are easily proved. Why is it doing that, the screen? It's moving. Okay, right. Firstly, a couple of results to prove. I'm sure that you remember that if we let z equal cos theta plus I sine theta, hopefully you recall de Moivre's theorem, which is that z to the n equals cos n theta plus I sine n theta, and z to the minus n is going to be cos minus n theta. I'm going to simplify it in a second. For those of you who are crying at the screen, simplify that, Mr. Nichols. I will, I promise. Minus sine n theta. Now that can be rewritten. The rules of cos are that cos of minus x, and this is on my board, my big trick shindig, is cos x. Yeah, really important, that one. And then sine of minus x, well, that's slightly different. It's minus sine of x. Technically, we call cos an even function because that holds, and sine is an odd function because that holds. But anyway, that means we can simplify this to cos n theta minus I sine n theta. Yeah, do put those in brackets so it's a little bit ambiguous. I should have done it over here as well, shouldn't I? Okay, so what? Well, this is what. Z to the n plus 1 over z to the n is therefore, because that second part of the expression is on the right-hand side, it's z to the minus n. If we added those together, the I sine n thetas would cancel, giving me 2 cos n theta. And likewise, z to the n minus 1 over z to the n, well, this time the coses will cancel, and we'll have 2I sine n theta. They're lovely results, and worth noting as well, in the special case where n is 1, you've got z plus 1 over z is 2 cos theta, and z minus 1 over z is 2I sine theta. Yeah, worth noting both of those two. Okay, so bear that in mind, because you're going to need that for the next kind of problem. The next kind of problem, I'm just going to say express and this is actually question 1D, express cos to the power of 4 theta in terms, I'm putting it slightly different to them, in terms of cos 4 theta and cos 2 theta, because they might not tell you the answer. And in the book, they do start by saying prove this and prove that, which is lovely, and they might well do that, but they might not. So just in case they don't. Okay, so how do we tackle these ones? Well, we let z equal cos theta plus I sine theta. And then we say, okay, in which case, z plus 1 over z to the power of 4. Well, remember, just here, I'll circle it in red, z plus 1 over z is 2 cos theta. This is why we're doing this, so we can find out what cos to the power of 4 theta actually is, and then apply de Moivres. So we're going to have to do 2 cos theta to the power of 4, which is 16 cos to the power of 4 theta. Never forget that, because it's really easy to forget to divide by 16 at the end. Yeah, but also, and this is where it gets binomially, we need to use binomial again. I was going to say binomially, and I don't think you can use that as an adverb or whatever that is. Speak to the English department for any complaints on my English language. Okay, so we can also use a binomial expansion here. Now, hopefully you know Pascal's coefficients for this one. It's 14641. It's dead handy if you know them in advance. Just write out Pascal's triangle if you're not sure. You're going to have z to the 4, and then you're going to have, this is going to be cubed, and that's going to be to the power of 1. But when you times them together, I'm just putting the Pascal's coefficient on, you're going to end up with z squared, yeah? Because you've got z cubed times 1 over z. Well, that's z squared. And then you're going to have 6 z squared times 1 over z squared. Well, they're going to cancel. And then you're going to have 4 z squared, well, we're going to have, this is basically going to be to the power of 1, and that's going to be to the power of 3. So you're going to get z to the minus 2. And then you're lastly going to get z to the minus 4. It will be, every time, beautifully symmetrical, this, yeah? Every single time. So make sure that yours is symmetrical, or you've done something wrong. I'm just going to get rid of that times sign because it's annoying me. It didn't look as symmetrical. Do you know what I mean? Okay, right. Okay, so we've got a lovely bit of symmetry there. Yeah. Now here's the trick, and it's such a clever trick. Z to the 4 plus 1 over Z to the 4. Well, we know that because, let me highlight this in yellow. Here's what we're going to use now to simplify this. This means we can write these as not, as in terms of cos 4 theta and cos 2 theta, because what I can do is I can group them, yeah, and maybe I will group them first. Normally I wouldn't do this line of working because these questions can end up very long. The more you do them, the quicker you'll get. Okay, I'm going to write it like that because that is simply, and I'm going to do 2 lines in one go, z to the 4 plus z to the minus 4, that's 2 cos 4 theta. Yeah, and then 4z squared, or 4 times z squared plus z to the minus 2. Well, hang on, that's 4 times 2 cos 2 theta, which is 8 cos 2 theta. And then lastly, we've got a plus 6. Now, don't forget, that is what 16 cos 4 theta equals. So let's write down 16 cos 4 theta here. And hence, cos 4 theta is, and now you can just simplify it, 1/8 of cos 4 theta plus 4 cos 2 theta plus 3. Yeah, and there we go. And that is basically how this entire exercise works. But yeah, it's not impossible. It really is not impossible. But I understand how you're probably looking at this book and thinking something along these lines. Where's that? I've got a little GIF to show you. Let's show you it. I'm sure you've all seen this before. I just wanted to say that. And yeah, it's like that throughout this whole chapter. It gets really into the thick of it now. Okay, hope you enjoyed that, and best of luck with the exercise. Every question except 1B and 1D. Good luck.